Welcome to the Explainer. So it's a frustration we've literally all run into. You've got a brand new massive USB drive with 100 gigabytes of free space. You try to copy a single high-definition 5 gigabyte video file onto it, and your computer just completely blocks you, saying the file is too large. It's incredibly frustrating, right? I mean, the space is obviously there, so what exactly is going on? Well, the invisible culprit behind that annoyance is something called a file system. Today, we're going to demystify exactly what that means by unpacking the mechanics of the absolute storage titans FAT32, NTFS, and EXT4.
Okay, let's dive into this. Here's our roadmap for today. 1. The empty parking lot. 2. 4 jobs under the hood. 3. Meet the big 3. 4. Features, flaws, and limits. 5. The modern bridge. And finally, 6. Your storage cheat sheet. All right, Section 1. The empty parking lot. Think about this for a second. When you hit Save on your computer, where does that file actually go? And I don't just mean which folder it ends up in on your screen. I mean physically, digitally. How does your hard drive know where to store that exact data, how to find it again a year later, and how to make sure a completely different file doesn't just overwrite it tomorrow?
That magic is handled by the file system. A great mental model for this is a massive, completely empty parking lot with thousands of spaces. Without a file system, that lot has absolutely zero organization. There are no signs, no painted lane markings, no numbering system. Your operating system would have no idea where any car or file is actually parked. The file system is the essential set of rules and data structures that brings order to that chaos. It tells the storage device exactly how files are named, stored, retrieved, and managed. Literally every single device you use, from your SD cards to your USBs and hard drives, needs one of these before it can store a single byte of data.
Moving right along to Section 2. 4 jobs under the hood. So what does this actually do? Well, a file system is essentially juggling 4 critical jobs all at once. First is storage. It physically decides which specific blocks on the disk hold the actual pieces of your file. Second is metadata. It acts as a detailed record keeper, tracking the file's name, its exact size, when it was created, and who actually has permission to open it. Third is directories. It builds that familiar folder tree structure so we, as humans, can actually navigate our files logically. And fourth, free space management. It constantly monitors which disk blocks are empty and available, ensuring new files always have a place to go without crushing old ones. Together, these 4 pillars are what let your computer read, write, and delete files reliably.
Which brings us to Section 3. Meet the big 3.
Now, there are dozens of file systems out there, but these 3 absolutely dominate the digital world. Contestant number 1 is FAT32. FAT stands for File Allocation Table, and it's the universal old-timer of the bunch. Introduced way back in 1996, it has been the universal language of storage ever since. When you buy a brand new USB thumb drive or an SD card from the store, it's almost guaranteed to be formatted as FAT32 right out of the box. Why? Because it works on virtually everything: Windows, Mac, Linux, gaming consoles, digital cameras, even your car's audio system. If it has a USB port, it can read FAT32.
But here is where we hit that massive roadblock. So, the crucial point is 4 gigabytes. FAT32 has a hard, unyielding maximum file size limit of exactly 4 gigabytes. You absolutely cannot store a single file larger than that on a FAT32 drive, even if the drive itself has terabytes of free space. Back in '96, 4 gigs seemed like an infinite amount of space, but today, a single 4K video from your smartphone or a modern video game installation easily shatters that limit. It makes FAT32 incredibly frustrating for modern, large workloads.
Enter contestant number 2. NTFS, or New Technology File System. Microsoft actually introduced this in 1993, and it became the absolute default for all consumer Windows machines starting with Windows XP. It was built specifically to fix basically everything that FAT32 couldn't handle.
Now, what's truly interesting here is the sheer scale of the upgrade. Remember FAT32's measly 4 gigabyte limit? NTFS bumps the maximum file size up to 16 exabytes. To put that into perspective, that's 16 billion gigabytes for a single file. So, for all practical intents and purposes, the size limits are completely gone. If you're using a Windows computer right now, your main C drive is almost certainly running NTFS.
But NFTS isn't just about size. It's really about enterprise-grade reliability. While FAT32 is completely open with zero security,
NTFS introduces fine-grained file permissions. It controls exactly who can read or write to a folder, which is why your Windows PC can actually have multiple secure user accounts. Plus, NTFS has this brilliant lifesaver called journaling. Imagine you're transferring a massive file and the power suddenly cuts out. On FAT32, that file system might get totally corrupted, leaving you with broken data. But NTFS keeps a journal, or a logbook, of every planned change before making it. If the power dies, it just uses that journal to safely roll back the incomplete changes when you reboot. Add in built-in encryption and compression, and you can really see why NTFS is the corporate standard.
And that brings us to contestant number 3, EXT4, the fourth extended file system. Introduced in 2008, this is the default high-performance workhorse for Linux distributions. Whether we're talking about a tiny Raspberry Pi or a massive Ubuntu cloud server that's literally powering the internet, EXT4 is likely running the show.
EXT4 was built for extreme performance and heavy workloads, and it utilizes some incredibly smart features. First up is extents. Older systems tracked large files by listing thousands of individual tiny disk blocks. EXT4 groups these into extents, which is basically a contiguous range of blocks. This means it can just say, hey, this file uses blocks 5,000 through 30,000, which dramatically speeds up reading and writing. Second is delayed allocation. When data is written, EXT4 actually waits a split second to see the big picture. This allows it to assign disk space much more efficiently and totally reduces fragmentation. And finally, journal checksums. It takes the journaling concept we saw in NTFS and goes a step further by verifying the journal itself against corruption. Honestly, it's incredibly robust.
Section 4. Features, Flaws, and Limits.
So we've seen how insanely powerful NTFS and EXT4 are, right? So why on earth does FAT32 still exist? Well, it all comes down to native operating system compatibility. FAT32 is the only one that Windows, Mac, and Linux can all read and write natively, right out of the box. NTFS is heavily optimized for Windows. Mac computers can read an NTFS drive, sure, but they can't natively write to it without installing extra third-party software. EXT4 is deeply loved by Linux, but Windows and Mac cannot read it at all out of the box. So if a manufacturer is selling a USB drive, they format it in FAT32 to ensure it doesn't instantly frustrate half their customers. Universal compatibility just beats performance for portable storage.
Next up, Section 5, the modern bridge.
But what about our 4 GB file problem? We still need to solve that. That's exactly where exFAT comes in. Introduced by Microsoft in 2006, you can think of exFAT as exactly what it sounds like. It's FAT32, but with that annoying 4 GB ceiling completely smashed. It supports those massive 16 exabyte files, but crucially, it is supported natively across Windows, Mac, and Linux. It drops some of the heavy overhead of NTFS, like journaling, which makes it incredibly lightweight and fast. If you buy a modern SDXC card larger than 32 GB for your new 4K camera, it's going to be formatted as exFAT. It really is the ultimate modern bridge for sharing large files across different platforms.
And this brilliantly illustrates exactly why understanding these differences actually matters to you. Section 6, your storage cheat sheet.
Here's the absolute distillation of everything we've covered today, your highly actionable guide. If you're formatting a drive, use this approach. Need maximum portability for older devices, car stereos, or just basic USB sharing? Use FAT32, but remember, no massive files. Are you setting up an internal Windows drive or an external drive you'll only ever plug into a Windows machine? Go with NTFS for maximum security and journaling. Are you setting up a Linux server or a dev machine? EXT4 is your undisputed king of performance. And finally, if you have a massive external hard drive and you're constantly swapping it between a Mac laptop and a Windows desktop, format that drive as exFAT. I promise it'll save you endless headaches.
File systems are just one of those hidden layers of technology that, once you understand them, completely change how you look at storage. So I leave you with this final thought and a bit of a challenge. Grab a USB drive or an external hard drive sitting on your desk right now, plug it in, and check its properties. What file system is it actually running? You might just be surprised. Thanks for joining me on this explainer. Keep exploring, and I'll see you next time.